Hello.
Hello.
Hi, how are you?
Doing pretty good. And yourself?
Doing great.
All right. You ready for a little interview question?
Yeah, sounds good.
Okay. So I think today we're going to do something just a little bit different than the usual, algorithms and data structures. And we're going to go and do sessions assembly language. Now, don't be too put off. I know no one's programmed in assembly language ever, but this is actually based on a game. I don't know if you've ever heard of it. It's called Core Wars. That was popular, I guess, back in the 80s or something, where you would program a warrior against other warriors and battle each other out in assembly language. It's kind of fun, and I think I've got a couple questions that take advantage of this.
Okay.
So if you're up for it, let's give it a try. Can you see what I'm typing here on the
Yes.
the screen? Okay. Perfect. Okay. So essentially, what's happening here is that we're going to be writing a program in a very simplistic language that's called Redcode. And if you really want to look it up, you can just look up Core Wars on Google, and it'll give you a little bit of introduction. But I'll give you everything that you need here. You don't actually have to look at it now.
Okay.
But so we'll just start off with the situation that we're going to want a little program that counts to 3 over and over again, and I'll show you how to do that. And then once you get an example of what this language looks like, then I'll ask you to sort of change it and that kind of thing.
Okay.
So the way this programming language works is that you just have some memory, some RAM, and you write instructions directly into the RAM. And you'll have a program counter that will read the instructions and move according to the instructions, and that's all it does. There's no files, there's no disk, there's no network, there's no anything. It's just a bit of RAM. So,
okay.
And the RAM is going to be sort of numbered in terms of slots, like memory locations. And I'll just go out to 16 locations now, just to give you an idea.
Yep.
And at every one of these locations, you will put in or for however many blocks you'll have, you put in the instructions for your program. So one of the instructions is called move, and I'll explain a little bit more about what this all does. But in any event, the way that the execution of the program is going to work is that you'll have an instruction pointer, which will start at the start of your program. It will execute that one command and then move on to the next one. And what this does.
By the next one, you mean the next spot in the RAM?
Yeah. So this one's number 2, and then the next one it will do number 3.
Okay.
What this one will do, so the arguments to move are basically the origin and the destination of which pieces of RAM you want to move to where. And
okay.
So what the number 5 is saying is that if 5 address spaces from now, you will copy that and you will write it to the destination, which is 6. So after
okay.
this instruction pointer finishes, then you will see that same instruction written once. So it's actually more of like a copy than a move, but that's okay. And then the instruction pointer will move on to the next one. So I'll show you what I'm going to put here is going to be add and 1 and 5. One thing to notice is that the addresses are relative. So you see that I used 5. It didn't write it to actual address number 5. It just went 5 ahead. And you're going to see that this is also true of all of the address spaces, or all the addressing. So add 1, 5. So add the parameters are the amount and the destination. So this will take the instruction. Oops, sorry about that. It'll take the instruction that's 5 ahead, and it will add 1 to it. So the instruction pointer moved to here, here, and then it will move and make the next one. So then I'm just going to repeat this a couple times. Okay. 3.
I'm sorry, what is number 1?
So number 1 is the amount to add to the thing. So so after instruction number 4, if we're here, then this will turn into 2, and after we execute this one, this will turn into 3, because you're just adding this number 1 each time.
I see. Mm-hmm.
And this is the address of where it's being written to.
Yep.
Okay, and if we go and try to execute one of these data blocks, that actually is a segmentation fault and the program exits. So you want to avoid that. So in order to not go into a just end the program, you will then say we're going to do a jump to -4, which is just the destination of where you want the instruction pointer to go to next.
Okay.
Instead of just increasing it by 1, it will, in this case, jump back 4, so that your instruction pointer will be pointing back here.
Yep.
And so what this will then do is it will start the whole thing over again. It copies this to here, and then adds up there. Okay, so here's the very first program, and it would basically start looking like this, and that would be the program that you will have written, and it will behave, and the starting point will be here, and it will behave as I just showed you, that it'll count to 3 and then start back over in this infinite loop.
Yep.
So does that basically make sense in terms of
yep.
what's going on?
Yeah,
okay.
Sounds good.
So, all right. Now, this is all fine and good, and you're happy in the land of your memory, and then the real challenge comes that another program jumps into your address space and starts using your CPU, and he is your enemy.
Okay.
So here, one last thing to mention. So I was talking about the how all the addresses are relative. So you see that this 5 isn't going to the number 5. This is going 5 ahead.
Yeah.
It points up to here. Yeah. So one other element about this memory is that it loops around. So that if you were down here and you said like move 1, 2, then this would go and impact that up there.
Yep.
So it kind of loops around a little bit. Okay. So here we are. Your enemy, should you choose to fight him, has written this program here. So now, what he is trying to do is destroy you. He's trying to, or basically he is in there, and I'd like you to tell me what's going to happen after once he starts running in your address space and with your CPU. So, and what I mean by with your CPU is that you guys will alternate the instructions, so that you will run one instruction, and then he will run one instruction, and then you, and then he. And
okay.
so forth.
And I get 0 through 7. He gets 8 through 15.
No. So you're in the same exact same address space. You both get 0 through 15.
Okay, but so I'll start at 2 and he'll start at 11?
Yeah, in this
okay.
case, yeah. So do you understand the question?
Yes.
Okay.
Well,
Well, I guess so. So I guess the first step is explain
so
what's going to happen, like with him sort of once you start the CPU running, what's going to happen?
So his move 0, 1 is going to start descending until eventually it starts hitting my instructions.
Right.
So,
and then what's going to happen once he loops back around?
So we're going to get something like where after, so I'll get to run six or seven steps, and then we'll get something like this, which will then move itself onto this block number 2.
Okay. So so he will basically start to overwrite your program.
Yeah.
Okay. And then what will you do?
So when this happens, I will be at, let's see, 1, 2, 3, 4, 5, 6, 7. So on the 7th step, he will have, on the 6th step, we'll have move 0, 1. And by then I'll have done 6 steps. So 1, 2, 3, 4, 5, 6. Oh wait, no, I've done the jump. My 6th step is again move 5, 6. So this will be that 0. I've counted once. I am back to here. Now I'm doing the 7th step. So hold up. 1, 2, 3, 4, 5, 6. Okay, so I've done that step. I will be here when he is here. So I will get to keep on counting this time. I move next. So this will become 1, and I move here, and now it's my enemy's turn. And he is gonna do this.
So it's actually the old instruction sticks around. It doesn't get erased, but just as just a minor.
Sorry, what happened?
So the old instruction, old move 0, 1 doesn't get erased. It stays there.
Oh yeah, sorry.
Yeah. So just a minor thing, but no, you're this is exactly right. Yeah.
Okay. So now I will keep on counting 2, and he is going to keep overwriting my instructions. Since these are all copies, so they're all over there, all over the place.
Right. Yeah, yeah.
Sorry.
Yeah. So we can just imagine that they're all there. That's fine.
Yep. So what it looks like will happen is that I will get to count to 3, and I will not get to get any further because all the instructions will be starting move 0, 1.
Right. Well, so what happens once you jump?
I will jump to the move 0, 1, so I will start executing the same instructions.
Okay. So he's kind of like a zombie in that he will have sort of taken your life from you, and then you just kind of plod on. Okay, perfect. Now, let's say that you know that this is the type of enemy that you are going to be facing. I'm just going to go and put back the original things. So then the question is, what can you do to stop him?
Sure.
And in general, I guess we can start with him being at number 11 now, but in general, as this game is played, you write a program and your opponent writes a program, and they're actually randomly placed in the address space. But let's just say, if you want to start with this, just starting at 11, that's fine. Or
so I guess if I know my enemy is doing this, one thing I could try to do is to keep a copy of my instructions somewhere. Am I allowed to do more than one command per register?
No, so each memory block is one single instruction. And
Okay.
oh, are you still there? Yeah. So another thing to keep in mind is you don't necessarily at this point have to be adding numbers to 3 anymore. So when you were alone by yourself, you were plenty happy to just add numbers, and that was all that you needed. But we can say that now you're in fighting mode and you don't have to be in counting mode. So the counting thing was just sort of expository about how the mechanics work. So you don't have to worry about adding numbers anymore.
Okay. So I just want some command that prevents it from being overridden.
Yeah. So basically, you're just fighting him. You're fighting him off in some way, shape, or form.
Okay.
And the way that you stop him is you get him to read a non like one of these data instructions.
Got it.
Like pseudo instructions.
So one second.
Yeah. No, this is the tricky part.
Okay, so I want to overwrite an instruction after he's done the move 0, 1. I want to put something in that place.
Right.
So for example, I can do so I move first, so I'm gonna need to pass 1 turn. So I'm just gonna do 0, 1. No, I don't want to do that. Jump
You can,
1.
or there's a no op if you want. That's also fine.
And the next thing I'm going to do is copy or move, I guess it's 4 to 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to copy this, oops, dat number 0 after my enemy moves.
Mm-hmm.
Does it make sense?
No. Right. So let's see. So you've got 4, 1, 2, 4, 2, 5, 6, 7, 8, 9. So he's going to first move
so
that.
I move
right.
first.
Yeah. So you move first. You're going to put the 0 in his place, and then you get him. Okay. Perfect. Yep. And that will stop him, and then you can write the rest of your program would be for counting numbers or whatever. Okay. Sure. Now let's say you don't know where he is going to be, and that he's going to be randomly placed somewhere in the address space along with you.
Okay.
And the only thing that you can be sure of is that the 2 programs won't overlap, that it will be in some relation of behind or ahead of you.
Okay. So when I write the program, do I just write 1 line?
No, you write all the lines of the program, and then
but I know that he's not going to overlap with my lines. Yeah,
that's the only thing that you know. So you will write all the lines, whether it's like 6 or 7 or whatever.
Well,
and then
the trick answer is that I'm going to write 15 lines.
Right. Good point. I think in the way that the actual game works is that there's a limit. There's a hard-coded limit to how long the program can be. I think it's like 30, and the address space is usually about 8,000 is how they
Okay.
use it. But no, that's a very good point. That if you had 15, then that would guarantee that you would be able to do it.
So one thing I can do is to make a little bot that instead of counting to 3 is just going to place these dats all over the place.
Mm-hmm.
Oops. This is not very efficient at all yet. 1 second.
That's okay. It's all right.
I guess I want to place something behind me to protect myself also. So I want to actually move.
Brings up an interesting point is that so you put that in front of you.
Yeah, I'm just going to put it behind me. Yep,
okay.
That's pretty silly. Unless he starts like 2 spots. It would have saved me if he starts like right in front of me, but that's kind of a waste of time. So I'm just gonna.
Eventually he'll make it behind you anyway. Like.
Yep. So the simplest solution is throw something like this. Oops.
Yep.
Does that make sense?
Okay. That does make sense.
It breaks if he starts one behind me.
And when else does it break?
Actually, no, it does not break if he starts one behind me because I moved first. So I do the copy into his spot first.
Right.
When does it break? Let me think. This might actually be fine.
So what if he started 2 behind you?
Oh yeah, sorry. I see. Oh, that's unfortunate. Yep.
Well, let's. So not meaning to discourage you. This is great.
Yeah.
And it does kill him under a lot of circumstances. But let's just flesh out what are the conditions in which he wins and what are the conditions in which you win. Or I guess he doesn't really win. He just zombifies you.
So the problem is that he is going to overwrite the move I have in front of him because if he starts on even squares.
Mm-hmm.
So I can make a slightly more efficient version, which is still not great, which is something like this.
Okay. So how what's the difference now? Like
the difference is that I am taking three moves, and I'm filling up 2 of his spots.
So then, in what percentage of the time are you?
I'm gonna win 2/3 of the time instead of half the time.
Okay, perfect. Yeah, and actually, and you've already sort of jumped ahead, and like the way that the tournaments like this work is that because there is a random element to where they start, they actually just do like 1,000 runs and take the average of
Okay.
you know. So then if you knew that you had a maximum of say 8, like that was the maximum size of your program, then what would the optimal size it look like? Don't even have to write it out, but just sort of explain.
6/7 because I need I need one spot for the dat and one for the jump.
Mm-hmm. And then the rest are these moves.
Yeah.
Perfect. Nice. That's excellent. That's excellent. Yeah, no, you did great. That's all I got. I mean, actually, if you're interested, if you think this kind of stuff is fun, then I would just look up Core Wars on Google. These are actually the real instructions and how it works. It's a lot more like involved than just this step, but no, you did fantastic. Like you picked up on it right away, all the different things, like how to optimize it. Yeah, so that was just a great job.
Thanks. That was actually a lot of fun. I don't know that I learned anything very practical, but it was fun to do.
Very good. Well, sometimes that's all you can expect out of an interview question. So, all right. Well,
do you want feedback?
Yeah, sure.
I guess the hard thing that I would have a hard time adopting this because I don't know. I'm spending the first 15 minutes without really getting any input about the candidates. So, I wonder how I would adapt it to get feedback sooner in terms of knowing where to go.
Right. I see what you're saying.
Mm-hmm.
Yeah. I mean, my basic sort of thought is, like adapting to a new like type of domain that you haven't seen before. I guess one problem that you see when you've interviewed a lot of people, or more like when people have done a lot of interviewing, is that they hear the same questions over and over again, and they kind of are just answering by rote. And sometimes someone who can like really program their way through a red-black tree, like with their hands tied behind their back, actually can't like adapt that like logical thinking to another thing. I mean, there's obviously pros and cons. You know, I didn't test whether you could like code a for loop, but I don't know. I feel like if you get the concepts behind like what's all going on here, and you can sort of move into that logical space, that I think that the other like parts of programming shouldn't be too big of a deal.
Okay.
But no, that's a good piece of feedback. It is like quite abstract, and sometimes the world doesn't necessarily need more abstractions. But in any event,
and also maybe you want to change the move function to a copy function.
Right. Yeah. I know it is. It's. I kept it as move because that's what the original is. But it is. It's kind of a weird. It takes a little while to get used to that nomenclature. But.
Okay, that's about it. Thank you very much. I had a lot of fun.
All right, great. Thank you very much.
Take care.